Hello there, this is Adam Harner, and this is my PowerPoint presentation on static electricity for Physics 101, Angela McClure class, Monday, Wednesday, Friday. What is static electricity? The science definition is an electric charge that has accumulated on an object. This electric charge is created when two objects are rubbed together and the electrons from one of the objects rubbed off onto the other one. We'll go into more detail about that later. Here's just some examples, like lightning is an example of static electricity, just on a large scale. That's not really what I'm going to be covering, exactly how that happens, but that's an example. This is more of what I'm going to be covering when you're walking along carpet and go to touch a doorknob, all of a sudden get a shock, boom, static electricity in action. This too, just a girl touching a static electricity globe and showing her hair going in all different directions. I'll show why I'll talk about why it does that later on. And here's just a cute little baby with the balloon rubbed against its hair and hair going towards the balloon. And I'll talk about that later. That's more of what I'm talking about. Our body and rubbing against certain materials and how the electrons are transferred and moving around and everything. So, where do we see static electricity the most? We see it the most when there is low humidity weather, which means there's less moisture or water in the air, so we have dry air. That is when we see static electricity the most. And why? Is because the water in the air helps scatter the electrons that we pick up as we move around. So when the air is dry, the electrons are collecting together and sticking to us, and then they build up until boom, zap, we touch something we regret. Not really, just kidding. Why is it often seen in winter? Not so much in Arizona, but other places, because we have our heaters on, which is sucking the moisture or water out of the air, making it more dry. Now we need to start all the way back at the atom. Why? Because atom is all matter. Everything's made up of atoms, and atoms contain different charges, which is what static electricity is all about. Different charges. Everything around us has a charge, which means because everything is made up of atoms, except for certain things, which I won't go into that. But the atom is made up of protons, which are positive, electrons, negatively charged, and neutrons, which have no charge. And the blue and red balls in the middle represent the nucleus, while the gray circular balls, spheres on the outside, on the shells or rings, represent the electrons. There are positively charged objects and also negatively charged objects, but most of the time the atoms are balanced, meaning they have no charge and equal amount of protons and neutrons, but in certain cases you could have more protons or more electrons. So in this case, when an object or atom is positively charged, it means it has more protons than electrons. So the positives, the protons, outweigh the negatives, the electrons. In a positively charged object or atom, it also means it lost electron or electrons to make it positive, and the object or atom is more likely to gain an electron later on, or electrons. So when an object is negatively charged, it's the exact opposite of that, meaning it has more electrons than protons. So the negative, or electrons, outweigh the positive, the protons, meaning it gained an electron to make it negatively charged. And this atom is more likely to release or give off its excess electrons to the positively charged ones, or neutral. Opposite charges attract to each other. So if you have a positive charge and a negative charge, they're going to want to move towards each other. While charges of the same charge are going to want to repel from each other. So a positive and a positive charge are going to push away from each other and not want to get near each other. Same goes for a negative charge and another negative charge. They both want you to get away from each other. Which leads to this. This is why our hair stands up. Like when we remove a hat or rubbing a balloon on our hair, positive electrons are, or our hair is becoming positively charged. So that means all these strands of hair are trying to get as far away from the other positively charged hair strands, and the only way for them to do that is stick straight up. That's the farthest they can get from each other, and that's why they do that. These are two of the three ways to get electrons moving from atom to atom. They're not the most common, but they do involve electrons moving. So we have electrons moving around as a result of pushing atoms together, combining them, or we can have electrons moving around from pulling objects apart, separating them. But the most common way that we see it, and what I'm mainly talking about when we're moving across that fuzzy carpet, going to touch that lovely doorknob, and bazing, we have this friction. What is friction? Friction is the interaction from rubbing or sliding motion of two objects or atoms against one another. And this is the most common way we see static electricity coming about. And it's the most common one we experience and can relate to. So when friction occurs between our hair or body and many different materials like carpet, wool, a balloon, and many others, there are extra electrons in those materials, the carpet, wool, balloon, that want to transfer or move to our clothing or hair, which then spread throughout our body and try to find a way out. Even if it's another person, dog, doorknob, that's why we can zap all sorts of different things. And the special note is the two materials rubbing against each other have to be more of insulators rather than conductors. But what are those? Let's find out. Insulators are materials that hold their electrons very tightly, while conductors hold their electrons very loose, meaning they can electrons can flow through them much easier. And insulators have electrons do not move through them very well, and examples of these are like plastic, cloth, glass, rubber, dry air, etc. While conductors, like I said, electrons move through these extremely easy, and all the examples are pretty much most metals. So, I'm pretty sure people are curious about that spark between your finger and whatever you're touching, whether it be another person, doorknob, dog, anything. So, as a result of the voltage, which can be from 20,000 volts to 30,000 volts, which your household appliances, which A microwave use around 120 volts, or such as refrigerator 240 volts, so 20,000 to 30,000. That's a hefty amount that can be stored up into your body. But as a result of the voltage, or electrons transferring from you to a doorknob or another person, the air between your hand and the knob gets extremely hot and instantly turns into plasma for a short period of time, of course. And plasma is the fourth state of matter among solids, liquids, and gases. The plasma that is created here gives off a bright flash just like a lightning bolt. That's why it looks like a lightning bolt. And similar to thunder, the pop or zap sound we hear from touching things or in the dryer, taking clothes out, is from the air expanding and shrinking or compacting extremely fast. So in conclusion, the level of moisture or water in the air is extremely important because we see a greater amount of static electricity when it is dry out. And everything starts with the atom because it contains protons, electrons, and neutrons, which electrons are the primary focus here because they're the ones moving around and doing all the work pretty much. And the protons have a positive charge, electrons have a negative charge, neutrons have no charge. When we have more protons than electrons, the atom is positively charged. When we have more electrons than protons, the atom is negatively charged. And the negatively charged one is more likely to give off or donate some of its excess electrons to the positively charged atom. Which is why when we go across fuzzy carpet, we build up electrons and we tend to zap all sorts of different things. And opposite charges attract to one another, while charges that are the same charge repel from each other, such as when our hair stands up. We have no idea why it does, but now we do. And the most common way to transfer or move electrons from one atom to another is with friction or rubbing. Some scientists have said it's not the actual action of the friction, but rather that it's increasing the surface area. But that's still being thought about. And after this friction or rubbing, it leads to excess electrons going through your body that want to get out as fast as possible. And once they can finally get out, a short instance of plasma is created, which looks like a lightning bolt. And the pop sound is the air expanding and shrinking rapidly. And these are my works cited. Boom, 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 boom. Hope you enjoyed. Have a great day and a Merry Christmas, everybody. I better have been